Okay, next we have our next measures of spread. We've seen range and interquartile range, which tell you something about how spread out the data is. But these standard deviation and variance tell you a little bit more. They're a bit more technical, a bit more detailed, and they involve every single point in the list. And what they're telling you is roughly how far away from the mean is each data point. So here we have a class of students and how many countries each of them have visited. If we want to find the standard deviation and variance, and they involve finding the differences to the mean, then we should start off by finding the mean. So 80 divided by 10 is 8. So how far away from 8 is each data point? Well, we can start subtracting. 8 subtract 2, 6, subtract 3, 5. Okay, and we get to points that are bigger than 8, we get negative results here from our subtraction. Now, we would like to find maybe the average of these numbers, but we've got a bit of a problem as some of them are negative, and that will maybe cancel out the positives and not really give us a meaningful answer. So we could do with making them positive somehow. Now we could find the absolute value, and there is a measure of spread that uses that, but we're not going to do that in IB. What we're going to do instead is square each point, because that will make them positive as well. So we start squaring each of these differences, and you can see even the negative ones become positive. Okay, so well, what's the average of these square differences? The mean of these square differences? Well, we can add them up. 544 divided by 10 again, we get 54.4. This is the mean of the squared differences to the mean, and this is what we call the variance. However, this doesn't really tell us exactly how far away from the mean each point is. Okay, 54.4. I mean, everything's been squared; it's a bit off. So what we can actually do is square root that and then get back to a more meaningful result that really does tell us, on average, how far away from the mean each data point is. So if we square root that, we get 7.38. Now this measure is what we call standard deviation. Okay, so they go hand in hand. The bulk of the calculation for these two measures are the same. Okay, just one is the square of the other. Okay, we can see we get this lowercase sigma for the notation for standard deviation, and there we can see that standard deviation is the square root of the variance, and variance is standard deviation squared. So at the bottom here we have another list of students and how many countries they've visited. Now you can see that this is much less spread out. Okay, only 1, 2 or 3, maybe a 5, but definitely nothing over 10 or 20. Okay, it is much less spread out. So we would expect a much lower standard deviation and variance, and indeed we do. We have 1.19, that's a lot lower than 7.38, and that is what we expect, given just if we look at the list itself, we can tell straight away that it should be less spread out, and our calculations show that as well. Now, you won't really be calculating this by hand very often at all. In an exam, IB exam, you'll only be asked to find it with your calculator, thankfully. Okay, so you can press Stat, Edit, and enter in your data into a column, then press Stat again, but then go across to Calc. Then the first option should be one variable statistics. You click on that, you'll get lots of things like quartiles, means, okay, but there'll be something there with the lowercase sigma, and that will be your standard deviation. If you want the variance, you can square that. Okay, finally, what happens if we have constant changes to every point in the list? Well, what happens if we added 2 to every point? How would that affect the standard deviation? well, everything's been just shifted up by 2. Okay, though this would be 4, 5, 6, 6, 6, and so on. And the mean would be shifted up by 2 as well. That has a new notation, this Greek mu, and that will now be 10. But if everything has been shifted up by 2 and the mean has as well, the differences would actually be exactly the same. Now, as the standard deviation uses those differences, that means the standard deviation will also be exactly the same. Now, what happens if we multiply everything by 10? Well, the mean, with some calculation, you could find that that would now be 80, 10 times bigger than 8. The differences, well, those would be different now. If we took the first point, 2, multiplied by 10, it would become 20. Now, what's that difference to 80? That's now 60. Okay, so you can see that those differences are also 10 times bigger. Okay, if the standard deviation is just the sort of average of those differences, then that will now be 10 times bigger as well. And if the variance is just that squared, well, that's going to be 100 times bigger. Okay.